Hi, our team is Dwellify, and our goal is to provide a service to find your future home quicker and easier using various and unique searches. So here's our homepage. On our homepage, we have a featured listing of the day, which is just a random listing we pulled from our database. It has various properties about that listing. Here's our first complex query, which shows the highest demand zip codes based on our demand adjusted price feature that we calculated using a complex query. And we can kind of adjust this number of zip codes we want to see and start running this query. So how we optimized this high demand zip codes query was we created materialized views for various parts of the CTEs in that query. Because this query is pretty static, we only filter by the number of zip codes. We can kind of store the results beforehand, and it dramatically decreases the runtime. And here we can see the top 10 zip codes that we determined based on our demand adjusted price, which is the unique feature we calculated. And also on the homepage, we can search by house ID. So if I want to search like maybe house ID 1 and the attributes of that, I can search that, and then I see the different attributes here. So now I can demonstrate our first extra credit feature, which is logging in and authentication. So I can log in. I can either put my email and password here, like by signing up, or I can log in with Google or GitHub. So if I log in with Google, it should logging me out automatically. And then if I go to my profile, it shows my name and my saved listings. So I can quickly show how to save a listing. So here's our like searches. We have house search and location search, and house search basically is like a page with various searches that display house listings based on various attributes. And location search is a searches that display zip codes based on various attributes. So for house attribute search, there's like these various parameters. You can adjust these, search, and it has these listings that match my parameters. If this is paginated, I can go to the next page, go to the previous page. Say I want to save this listing with ID 11431. I can click on that listing, I save it for the future, and I go to my profile, and that listing is here, 1431. I have my location attribute search, which searches listings based on location attributes, weather attribute search, which searches listings based on weather attributes. I don't really need to show those right now. If I go to location search page, I can search for zip codes based on various location attributes, which is here. And here's my next complex query, which is searching zip codes based on neighboring locations. So how this works is that it looks at neighboring locations. So like for a zip code, it might look at neighboring cities if I choose city, or counties if I choose county. And it filters by these different metrics. So maybe I want to filter by population, and I want to filter the neighboring cities that have really low population. So I find a zip code with neighboring cities that have really low population. I search that. It's pretty fast, and it gives me the zip codes with neighbors that have low populations. How we optimized this query was we created materialized views for stuff in the subquery because we were joining multiple tables in the subquery every time, which increased the runtime dramatically. We also created indexes for the joins in the subquery. My next complex query is this complex weather search, where I can search by different types of events, rain or snow, and I can search for zip codes that have a minimum of like 27 events and a minimum frequency of 0.4 of those events. And how we optimized this query was we created more materialized views. There's only two types of events here, rain and snow, so we can create a materialized view for each and then kind of reference those. We also created indices for common joins in the query, which dramatically reduced runtime. Finally, we have a state statistics search here, which searches for ideal states based on the number of zip codes, number of listings, etc. in that state. So if I search for like a random state, maybe Georgia, I search for that, then it returns the number of zip codes, number of listings, and number of severe weather events in that state. And how we optimized this query was, once again, we use materialized views and indices to kind of dramatically reduce the runtime. There's only one parameter here, which is state. So we just had to make sure that the materialized view didn't calculate that state, and we left that open for the code. Now I can kind of show our second extra credit, and our second extra credit does code coverage. So we ran code coverage on all of our backend routing. And if you see here, after I run npm run coverage for my server routes, it covers 78.94% of server.routes. But the reason it doesn't cover 100% is because we don't actually test our authentication routes, but it covers 100% of our DB routes. Finally, I can show you the timings of each query. So for the neighboring locations query, before optimization, it was about 150 seconds, and after it was about 11 seconds. Complex weather query is before optimization, it was 27 seconds. After optimization is about 1 second. For state statistics query, before optimization, it was 18 seconds. After it was 4. For high demand zips, before it was 11, and after it was 0.25.